We're going to talk about Pluto. Pluto is not a planet, and I'll explain why it's not a planet. First of all, let's talk about how Pluto was discovered. So I'm going to do this in a little different order here. But Pluto was discovered in 1930 by a guy named Clyde Tombaugh. Clyde, I think, was from Indiana. He was an interesting character in himself because he grew up on a farm in Indiana in the early 1900s. But he had a fascination for astronomy. And he really wanted to do astronomy, but he couldn't go to college. He didn't have enough money or anything. So he actually hitchhiked his way down to Flagstaff, Arizona, where they had the Lowell Observatory, built by a rich Massachusetts man, to study Mars in the early 1900s. But the observatories there, they had these telescopes. Clyde got on there working as a janitor because he didn't have any qualifications as an astronomer. And he started working there, kind of part-time doing things. And then they had this job which they were looking for new objects in the solar system. And when he did that, it was very tedious work. You'd have to take pictures of the sky each night. Back then it was photographs where you'd take the pictures for several hours, then you'd go down to the darkroom and develop it. And you would then compare it from one night to the next. And it was very, very tedious work. And the astronomers that were there didn't want to do this because it was repetitious, it was tedious. And so Clyde said, hey, he would do it, and he volunteered. And so what he was doing was taking pictures of the sky. And what he found was that he took pictures and he saw these stars. Like this. And then the next time he took a picture, it looked like that. So he took these two pictures, one on January 23rd, one on January 29th, 1930, and he realized that all these stars, these ones right here, were the same. But this one had moved. Well, if it moved, it's not a star. It has to be something in our solar system. And he realized, he started watching it for many nights, and he realized how far it is, how fast it moved, and he could calculate its orbit, and he realized he had found an object out there beyond Neptune. And so he discovered Pluto. Now he discovered this way back in 1930. Now, when they started to learn about Pluto, they found out some interesting things, that it really wasn't like any of the other planets at all. So, let's look at Pluto's statistics now. So, before I get to that, so Clyde Tombaugh was the one discovering, he used photographs. So by this point they were using photographs to discover it. And they had this cool thing called a blink comparator, where you put one photograph from one night, one photograph from the next night, like a week later, in this machine, and you put your eyes in there with kind of like a binoculars. You had one eye, and one eye would look at one picture, one look at the other. And then he had lights that would flash back and forth. Now, what it means is you would see this eye, and then you would see this eye right afterwards. To your brain, you would seeing one eye and the other, but all the stars that line up would line up in both pictures, so they just don't seem to move. But anything that changes position would blink. They call it a blink comparator. It made it easy, especially when you didn't have stars with like 6 stars in here. You would take pictures and there might be 1,000 stars in there. Trying to figure out which one moved is really hard, unless you do something like this, and then when you look at it, it is very clear the one that's blinking is the one that's moving. And that's how he discovered it. And back in 1930, when he discovered it, they decided, well, what were they going to name it? And that actually became a kind of a worldwide thing where they said, send in suggestions for naming the new planet. And Pluto is what they came up with because it was so far away, it was so dark. It was more interesting when it came out later that it had a moon. So we call it Pluto and Charon. Here it is, a picture of Pluto and Charon. And so we actually call this a double planet system. Why? Because size-wise, they're very close in size. Charon's about half the size of Pluto. And so it's not like Charon's actually going around Pluto. They both go around their center mass in between. They go like this, And they're both centering the circle, and then the whole circle is going around the sun. So let's look at some details here. The semi-major axis is about 40 AU for this system, so that its period is 248.6 years. So it's going to be a long time from 1930 until Pluto has gone around once. Now this is where things get a little more interesting. Its eccentricity, remember that's how non-circular orbit is 0.206. All the other ones are about 0.0, 0.05. The only other one that's close to that is Mercury, because it's very close to the sun. But all the other planets are pretty circular orbits. So that's your first clue there's something different. The other thing that was very different about it, and that's why people started wondering if it really should be called a planet, is that all the other planets go around here. So Neptune, Jupiter, Uranus, they all go around in the same plane called the ecliptic plane. Meaning, remember the ecliptic is the path of the sun around the celestial sphere. All the planets follow that plane, and you're going to find them all within a few degrees of that. Not Pluto. Pluto has a highly eccentric orbit, so it's tilted and goes like this. So this would be Pluto's orbit. So it doesn't match the same plane. So it did not form out of that same disk of spinning materials that created all the other planets. So it was created in a very different way. And it's very eccentric, and not only that, if we look at it from the top, here's Neptune's orbit. Here's Pluto's orbit. So it goes out here, but for a short part of its orbit, it actually gets closer than Neptune does. Now they don't cross, they'll never hit, because when it's getting closer than that, it's below the plane of the ecliptic, so they're not going to ever hit each other. But from 1979 to 1999, so 20 years of its 248-year orbit, it was closer to the sun than Neptune was. So it didn't last. And so from its orbital characteristics, we know it was formed very different than the other planets. And so if it had been discovered any time in the last 30 years, from about 19 or 40 years, from about 1970s on, it never would have been called a planet to begin with. The reason it was called a planet back in 1930 is because we didn't know any better back in 1930. It was going around the sun, and you could see it, barely. It was very faint, but it was possible with big telescopes to see it. Now the moon, Charon, was discovered in 1978 by a guy named Christie. I think it's James Christie. And in this case, to name it, they had a contest, and a lady from England actually came up with the idea Charon to name it. And you can also pronounce it Charon, okay? If you remember your history, Pluto is the god of the underworld, your mythology. And to get to the underworld, you have to cross the river Styx. Charon is the ferry boat driver that gets you across the river Styx. And so it fits in with the Roman mythology. Also, Clyde Tombaugh's wife's name was Sharon, which you can pronounce as Charon. And so it's very similar to that. So they thought, oh, hey, that kind of works. And so that's what it was named. And he discovered that in 1978 using photographs still to find that. Let's talk about some of the other characteristics. Let's talk about the diameter. The diameter of Pluto is 2,370 kilometers. And Charon, this is Pluto, the diameter of Charon is 1,212 kilometers. About half its size. All right. Do you remember how big the moon was? Remember, the moon was actually 3,000 kilometers. Pluto is smaller than our moon, significantly smaller than our moon. Yeah? In fact, if you look at the moons in the solar system, which we're going to talk about next after we're done with Pluto, Pluto isn't even one of the top 10 largest objects in the solar system, and that's ignoring the planets. There are much bigger objects out there than Pluto. So, not only did it have weird orbital characteristics, but it's very small. And when you get out this far, the objects that are out this far are mostly made of ice. I mean, it's almost all ice. There's not a lot of solid material there. The interesting thing, too, about its period, is I told you they orbit each other. I'm sorry, they orbit about the center of mass. Got to do this right. Pluto goes like this, while Charon goes around like this. So they're orbiting a point in between. They're spinning around like this. Okay, that's 6.4 days. So the rotation period, and is 6.4 days, and they're tidally locked, which means they always keep the same side facing each other, like two ballroom dancers dancing around. Neither one of them spins independently of the other. Because they're so close in size, they tidally lock each other. Like we tidally locked our moon, so one side always faces us, but we spin around because the moon's tidal pull wasn't strong enough to do that. Now we learned a lot about Pluto when the New Horizons spacecraft went by there about 5 years ago or so. This was the best picture we had of Pluto from the Earth. All we could tell, this is the actual picture, this is what happens when you clean it up using computer technology, but all they could tell was that there were some light spots and dark spots. It was so far away and it's so small, we could not tell any other detail. Really didn't know anything about it. But before it even got there, not only did they know about Pluto and Charon, but they found 2 more satellites. In fact, it's a whole system here, which is what makes this complicated. Alright, but the best pictures came because we had a spacecraft. The funny thing is when they launched the spacecraft, in I think